Okay, so I go to my Nusselt number correlation, and I have the Nusselt number is equal to 2 plus 0.4 Reynolds number to the 1/2 plus 0.06 times the Reynolds number to the 2/3 times the Prandtl number to the 0.4 times the ratio of the viscosities mu infinity over mu s to the 1/4. Okay, start to plug things in. 2 plus 0.4, my Reynolds number, 1.461 times 10 to the 5 raised to the 1/2 plus 0.06 times my Reynolds number, 1.461 times 10 to the 5 raised to the 2/3 times the Prandtl number, 0.7336 raised to the 0.4 times the ratio of the viscosities, 1.426 times 10 to the minus 5 divided by 1.802 times 10 to the minus 5, and that raised to the 1/4. So I do that, and I get a Nusselt number of 283.2. Okay, so I can now go to Newton's law. Okay, Newton's law of convection. Newton's law tells me Q dot from the head, that has to equal H times the surface area times the temperature difference, Ts minus T infinity. The Nusselt number, I can plug in the definition of heat transfer coefficient, H. I can plug in the definition of my Nusselt number. So H is just equal to the Nusselt number times K divided by D. My surface area, it's a sphere. The surface area of a sphere is 4 times pi r squared, and multiplied by the temperature difference, Ts minus T infinity. Okay, so now I can start to plug in some numbers. Q dot from the head is 21 watts. That has to equal the Nusselt number, 283.2 times K, 0.02439, divided by the diameter, 0.3, times 4 times pi times the radius, 0.15 squared, times Ts minus T infinity, which is 10 degrees C. Okay, one equation, one unknown, rearrange, solve for Ts, and I will get that the surface temperature is 13.2 degrees C. Okay. So the last thing to note is that we've now found that our surface temperature is 13.2 degrees C. We had that initial guess that my surface temperature was going to be 15. So I'm off by 1.8 degrees C, but that will have a very small difference in the viscosity. Only one degree will not affect that viscosity value very much. So this would be where we can end.